Power rules for exponents. Let's take a look at an example to see where we're going with this section. So if you have 4 to the 5th and you cube that, so these power rules deal with a power, 4 to the 5th, that's to another exponent. So what happens when we get a question like this? Well, I know what cubing means. Cubing means take the number and multiply it by itself however many times that exponent says. Cubing would be 3, so 2 cubed is 2 times 2 times 2. So 4 to the 5th cubed, by the same idea, is 4 to the 5th times 4 to the 5th times 4 to the 5th. That's all that cubing means. So this is repeated multiplication. It's 4 to the 5th times 4 to the 5th times 4 to the 5th. And we've seen in the past that this is just add exponents. 4 to the 5th times 4 to the 5th is 4 to the 10th when you add those exponents. And that still multiplies by 4 to the 5th. And when you have the same base and you multiply, you add those exponents. So hopefully you can see that there's a shortcut to go from this original question to the answer without having to do all those intermediate steps. And there is, and it's called the power rule. And the power rule states if you have a to the m, so a is your base and m is your exponent and a to the m is your power, and you raise that to another exponent, you take m and n and you multiply them together. Important enough to put in a big box. Let's take a look at a few examples of this. Example number 1, if I have 2 to the 4th to the 6th, I get 4 times 6, which is 24. If I do 3 to the 10th to the negative 2, it works exactly the same. This is 3 to the negative 20th. If I have 5 times 3 all squared, there's a couple of different ways you can do this. If you follow BEDMAS, you'll do 5 times 3, you'll get 15, and then square that, and 15 squared. Notice that one isn't too big a number, so 225. We could write that out if we wanted to. Another way to do these ones is you can square, when you have multiplication of 2 numbers or 3 numbers, you can square each of the numbers inside. So an alternate way to do 5 times 3 squared is 5 squared times 3 squared. This only works if this is multiplication. That's the only way that you can use this shortcut. Has to be multiplication. I'll put that down as a separate rule in a second. And then 5 squared, if you wanted to calculate that out, is 25, and 3 squared is 9, and 9 times 25 is also 225. If you're dealing with a fraction, like 2/7, and it's cubed, and a fraction is just the same as division, well, guess what? You can do, kind of like we did with the multiplication, you can do the exponent to each part. So this can be 2 cubed on the top and 7 cubed on the denominator, and that's 8, and 7 times 7 is 49, times 7 is 343, if you were asked to calculate it out. So these two methods here have a couple of new rules to them. If you have a times b to the n, you can, and it must be multiplication, you can do a to the n times b to the n. If you have a divided by b to the n, you can get a over n, a to the n over b to the n. And let's put that in a red box to indicate that those are a couple of new rules. There is a restriction on this one. We can't allow the b value to be equal to 0 because you're never allowed to divide by 0.